Hi everyone, and welcome to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based in Singapore. Liam Tong is a technical program manager based in Australia. He's going to use his professional services organization experience and talk to you about how you can secure your workloads in Google Cloud Platform. Remember that at any time you can ask a question below, and we have technical experts standing by ready to help. So hold on while I transfer you to Australia.
Hi everyone, my name's Liam, and today I'm here to talk to you a little bit about the security capabilities on Google Cloud Platform, and specifically how you can secure your enterprise applications and workloads in the cloud. Before I start, if you're watching this webinar, you're probably well aware of some of the threats that enterprise security are under in recent years. And it's not uncommon to be faced with headlines in the news about a recent compromise of a company. Unfortunately, we live in a time where large compromises happen quite frequently, and you can see here over the recent years a number of large events, security incidents, which involved millions of accounts, sensitive data records and credit card information, as well as an increasingly large number and size of denial of service attacks. In a cybersecurity report by IBM last year, they found that the average enterprise is faced with over 1 million security-related events on their networks and on their systems, out of which 20 of them could have been possible attacks, and over 3 security incidents, actual security incidents, happening per week. And that's a staggering amount when you think about the remediation that's required to deal with that. What we're seeing is that a lot of organizations are turning to cloud providers in order to improve their security capability. And they do this because of the benefits they get from these companies investing in security. So they take advantage of economies of scale to improve their own security. So what I'd like to share with you a little bit about today, first up, is how at Google we design our infrastructure, how we look at security across our stack. So let's talk about our infrastructure design. Historically, enterprises have kind of looked at security from a perimeter perspective, where there's a hard outer shell, but once you get past the perimeter, there's a soft center. As you can imagine, attackers can find on the inside that security defenses and protections may be a lot weaker, so that it's much easier to wreak havoc. Here at Google, our infrastructure has been designed with a design principle of avoiding this concept of inside and outside. And to that end, many Google services have their endpoints by default open and accessible on the public internet. And to achieve that, we've had to design extensive defense in depth into our systems throughout the whole stack of our infrastructure. And I'm going to talk a little bit about that. As you can imagine, when we look at the whole stack, you've got to go all the way back to the supply chain. So everything from the hardware that we use, the software stack that we run, the network which we serve our users on, and then the end user protections on devices and authentication at the user level is all within scope for thinking about comprehensive security. If we go a little bit deeper, at Google we think about security across multiple layers, where each layer has its own capabilities that integrate with each other, so that we can provide defense in depth at scale across millions and billions of users, in fact. So for each layer, we've designed and deployed specific security capabilities. And for example, if you look here on the bottom, we've built purpose-built hardware components that allow us to secure our boot stack as well as the operating systems that our servers run on. If you move up the stack, as we look at data protection and storage, we have encryption at rest as well as in transit, because at the network layer, we have the advantage of one of the world's largest global private networks. You might expect that building all this and running it takes a lot of investment. So we've actually got quite a number of security engineers and software developers. I think over 600 is the latest number of people that are focused specifically on designing these systems and improving them so that we can continuously get ahead of the security threats that are out there that are putting our infrastructure at risk. And what we've been trying to do with Google Cloud Platform is make much of this capability accessible to our customers through the native design of the infrastructure itself on which Google Cloud Platform runs, but also through technologies that we've built internally and externalized through different services. So you can see here a list of a few of the technologies that we've launched recently. For example, the Identity-Aware Proxy, which is something that we launched very recently, and I'll talk a bit more about, as well as the Cloud Key Management Service, which helps you to encrypt your data in the cloud, and also data loss prevention, which allows you to classify sensitive data that you store in our systems. So we've just briefly touched on the infrastructure design. So to find out more, I'd encourage you to look at our white paper that we've published recently about our security design of our infrastructure, as well as a whole bunch of other resources that are available that talk about how we've designed and built our systems at Google. But let's talk now about how you can secure your workloads on Google Cloud Platform. And to do that, I'm going to take an approach a bit like peeling an onion, but we'll start from the middle. I want to talk firstly about the secure VPC, which is the way in which you can develop and configure secure private networks on Google Cloud Platform. To introduce the idea of security on Google Cloud Platform, I'd like to start just by giving you an overview of how resource hierarchy works, or permissioning works in GCP. At the highest level, we have a concept called an organization, which is the container for inside which all of your enterprise workloads and services will run in. Below an organization is the concept of a folder, which allows you to group logical groupings of projects, perhaps by department or by purpose. But within folders, there are the projects. Projects are a grouping of services, and usually customers deploy projects based on environment, for example, a dev or a test environment. Within projects, that's where you have your actual resources, the services that do stuff, like compute engine instances or Google Cloud Storage buckets. So permissioning works on a hierarchical basis, and policies are inherited from the top down. When we come to talk a bit about networking and other concepts, we'll come back and refer to these ideas. When you think about identity and access management, a good way to think about it is which user or who can do what action on which particular resource or service on GCP. So from a user perspective, that's what controls the identities and authentication. And then the authorization is the what. That's where you set your policies and permissioning over the actions on the resources, such as creating cloud storage buckets, for example. Just a little bit about best practices on identity and access management. The first thing to always think about is granting permissions and roles to Google Groups rather than specific users. You can see here an example on the right of org admins as well as instance admins. And this basically gives you a higher layer of abstraction so that if someone leaves, you're not going to lose access, for example, to your instances or to your whole organization, hopefully. The second one is using predefined roles in Google Cloud Platform instead of native permissions like individual permissions. We've got a whole suite of predefined IAM roles, and we've actually got the ability to create custom roles coming very soon. The final best practice I just wanted to touch on was to grant roles at the least privilege required. So, for example, on the right here, we've got a compute instance admin who only has the ability to, for example, start, stop, create instances, whereas the organizational admin will have the ability to take action across the whole organization's resources. Okay, now that you understand a bit about IAM, I want to talk a bit about the networking options that are on Google Cloud Platform. So to step through this, from a virtual network perspective, firstly, Google Cloud Platform allows you to create software-defined networks simply through the Cloud Console, through configuration. And what this lets you do is create networks that are global in nature and span across multiple regions. You can also have the ability, as of recently, to have cross-project networking. As we'll come to in a second when I go through an example, networks are by default restricted to an individual project, and nothing outside of that project can get access to those resources on the network. If you do have scenarios where you want to allow access from other projects or even other organizations, you can deploy cross-project networking to allow for this. From a control perspective, we talked about roles. In the networking space, there's the ability to set network-related roles. We can have, for example, a network administrator that will be responsible for setting up the networks and managing the networks. From a policy perspective, on your infrastructure, there's the ability to create and configure firewalls, which give different levels of access to resources on your network. And then from a visibility and diagnostics perspective, we do have audit logging to track all actions taken on your environment, such as the creation of instances or the modification of networks, as well as Stackdriver, which is a logging and monitoring capability which captures events that are happening and allows you to inspect what has happened on your environment. As you move out beyond Google Cloud Platform, and connectivity-wise, you probably start thinking about how do I connect into my on-premise network or managed environment, or how do I connect to other cloud providers as well? And to do this, I'll talk a little bit about the options you have in Cloud Interconnect, as well as Cloud VPN for securing private connectivity between networks. And finally, how do you deploy your services at scale globally and secure them? Well, we have a few services there which can help with that. Google Cloud Load Balancing, as well as our CDN service, allows you to serve your users no matter where they are with low latency, with optimized performance, and with auto-scaling through the load balancer. So I'll come back to that in a moment. But to make things a little bit more real, I'd just like to go through this topology, this example topology of a basic VPC, in which there are two projects here. You can see on the left here, we've got an analytics project, which is a production project, which might be managed by a particular DevOps person. On the right side, you see a test environment, which has a web server, which contains a load balancer and maybe some servers, but that's managed by a separate administrator. And surrounding that, from a networking perspective, there's two networks in play here. One's the production network and one's the test network. And as I mentioned earlier, these are completely isolated by default in GCP projects, and you can manage them independently, and there's no way that any of these resources can talk to each other on between the two private networks. As you might expect in a scenario like this, you'd probably have different network administrators as well for production and test, so you can see them on the left and right. So in this scenario, any communication that happens between these projects can only happen through public IP addresses, which would mean going across the internet out of Google Cloud Platform and back into Google Cloud Platform, depending on the network environment that you're on, to have communication between these projects. But the second example I want to talk about is a new feature that's launched recently into beta. We're calling it VPC network sharing, also known as cross-project networking or XPN. In this scenario, we have three different projects. We have a web server in production, we have an analytics server, and we have a database server, all with separate administrators, isolated with the least privilege permissioning, which I referred to earlier. They can only manage what's inside their environment. But let's say you have a need to connect these systems together. To do that, we've enabled the ability to share a network between these projects. And this is where you'd have a security network administrator come in to manage this network independently from those other administrators. So what they would do is set up a private IP space where you can set up a network that spans across multiple projects. You just need to have the permissions as a network security admin to connect these projects together, and you can define the connectivity between these projects. So this is something that customers have been asking for a while, and we're very happy that this is launched and into beta, and we're seeing a lot of interest from customers. But when you get to securing your actual instances, one thing you'll want to look at is the Google Compute Engine firewalls. This allows you to secure the firewalls between VMs from an ingress perspective, so you can control exactly which sources have access to a particular instance. But you can also secure inbound and outbound traffic to the internet to specific instances as well on your network. But let's say you have a private, let's go through a few scenarios where you have a need to connect to VM instances directly, say for example over SSH. There's probably two main scenarios to think about here. One is where you have a VM with an external IP address. That's fairly straightforward. You just have to make sure your firewalls are set up correctly to allow access. And then you, well, on HTTPS and SSL if you want to connect over those protocols. And then you can connect directly into that external IP. For VMs without an external IP address, as you can see here on the right, we have some. The way to connect into this, so the design pattern would be to use bastion hosts or a jump host in which you can connect externally to, and then SSH into other machines from that box, or set up SSH forwarding to other instances. We also have the ability to set up an IPsec VPN if you need to connect into private address space in your VPC. One thing to note is though in this scenario, you want to make sure that you have a NAT gateway set up on that bastion host so that you can route traffic back out to the internet from those private instances. Okay, so let's talk about a different scenario where you've got some instances that run on a private network in GCP. You may not need to access those servers directly from the internet, but you want to make use of some of Google's APIs across the stack. For example, connecting to Google Cloud Storage or connecting to some other APIs, maybe some of the machine learning or predictive APIs. So the way to do this until recently was to was requiring you to have a public IP address where you would go out through the internet and then hit the Google APIs. Of course, since conceptually this is all Google infrastructure, you wouldn't expect that to be the case. So what we've launched recently is the ability to have private access to Google services. And what this allows you to do is to not be required to have an external IP, but to just go directly from that private instance to the APIs. That also save you on egress traffic and make things a lot simpler from a security perspective. Okay, so we've talked a bit about the core of your network, the secure VPC. Let's broaden it out and talk a bit about the ways in which you can connect into GCP's network. So I alluded to this earlier, but Google Cloud Platform sits on top of Google's global network, and you can see here that we have in green we have 7 regions around the world currently, with varying number of zones within each of those regions, and we have a number of other regions in blue here that are committed for launching this year. Each of these regions sits on top of our global network, of which the links are actually shown here, as well as on our website. And we also have over 100 points of presence on our network, which are really the edge points of our network, which you'd be connecting to as a user. You'd be connecting to your closest point of presence as you reach Google's network from your connection, your internet connection. But the way to connect into GCP is by a number of options. Firstly, you obviously have the public internet, which is the simplest and most resilient way of connecting to Google's edge network. But at the other end, on the right here, you have something we call direct peering, where you can actually directly peer onto Google's network. This has some requirements that come with it, so I refer you to our website to make sure you across those, and they sometimes change. But I think at the moment you have to have things like a 24/7 knock and a few other things. But if you don't meet those requirements, you can actually use a service provider to take an approach of carrier interconnect, is what we call it, where you use a service provider to provide you an SLA on your connection between your network and Google's network, and they will control that traffic and get you onto the Google network. And there's a lot of different providers out there, and they have different functionality and features in terms of the ability to dynamically control the amount of traffic, capacity, and to monitor your links there. But it's important to note that for each of these options, they are all traversing the public internet. So if you're looking for a private connection into Google's network, the way to do that is to use VPNs. We have a service called the Cloud VPN. This allows you to set up a private connection into GCP. And the way this works is you'll need your own static IP, and you'll configure GCP to connect to that VPN endpoint using IPsec. Obviously, you'll also need to have some private address space reserved so you avoid overlap between the networks. And what this looks like in this example here is your network on the right, or your other cloud provider's network, which has its own private subnets, and a gateway which houses your VPN endpoint. And then on the cloud platform side, you'll set up your subnets, and which may be in one region, and your overall network in GCP, which may span multiple regions. And then you'll set up the Cloud VPN, which will establish that VPN tunnel to your VPN endpoint. Now, if your network that you're connecting from supports BGP, we do have a service called the Cloud Router that will help you dynamically discover routes through the VPN, which can ease maintenance and of the VPN. For example, you don't need to keep stopping and starting the Cloud VPN when your routes change or when your IP addresses change. So there's that service there as well. So let's broaden out the circle a little bit more, and let's talk about something that was launched recently called the Identity Aware Proxy. The Identity Aware Proxy is really something that we've made available based on a use case, a very strong use case we've had internally, to have different tiers of access for different users in the organization. And the way this plays out is, for example, if you have an employee, number one, who has access, or you want to give access to all your systems or multiple systems, in here represented by the ERP and a CRM system, for example, you can do that and give them access. But if you have a contractor or another employee that only requires or only should get access to a subset of those systems, you can use the Identity Aware Proxy to make authorization decisions or access decisions based on their identity. So it's really just a perimeter around your infrastructure, a boundary that allows admins to dynamically configure who should have access to what applications. And what that does is I guess helps your developers and frees them up to actually focus on building the web apps or deploying the apps without having to think too much about security, because the Identity Aware Proxy takes care of the access control, but also handles TLS termination, as well as brings with it protections against denial of service attacks and other security concerns, which I'll touch on a little bit more. So I'd like to talk about the last two layers together, and they are the Cloud Load Balancer and CDN, as well as the Google Network. These two layers go hand in hand. We've talked a bit about the Google Network, but I'd like to start this topic by sharing an interesting incident that happened late last year to Brian Krebs, who some of you may know is an investigative journalist that looks at cyber criminals and criminal activity online. He was suffering quite a major attack late last year, to the point where his provider at that point actually asked him to move his site somewhere else because they were unable to deal with the attack. So he happened to reach out to Google and talk about with us this service that we have called Project Shield. And I don't know if you guys have come across this, but Project Shield is something that we have made available for free to organizations that publish news or publish human rights issues or not-for-profit agencies. And it's a service that we're promoting for free or giving away for free because we're trying to promote the freedom of speech on the internet. But Brian Krebs came to us and he started working with our teams who noticed some huge attacks happening to his website. But they I guess took it as a way that they could validate some of the defenses on Project Shield and on our Google network. And they actually were able to get his site back up very quickly by using Project Shield's defenses against denial of service attacks. And I wanted to share this with you because the same technologies that are in Project Shield are actually available through Google Cloud Platform on the load balancing and cloud CDN services. And to elaborate on that a bit more, I just wanted to go into this example here of a globally deployed application. Let's start from the top left here. Let's look at some users that may be connecting, for example, from Sydney. So they'd be connecting to Google through our Edge network. If they're reaching out for content that happens to be cached in one of our CDN endpoints, which reside in our points of presence, then they'd get served content right from the edge and they'd be getting low latency response times. However, if you have another user connecting from somewhere in Asia, for example, Singapore, they may not have the content cache there, so they'd fall into the load balancing, which then takes them into the GCP network that this example has set up, which I'll talk about in a second. But in both of these examples, these services both run at our edge, the edge of our network, through our points of presence. And these two services both have inbuilt protection for Layer 3 and Layer 4 denial of service attacks. So attackers will be prevented at that point from performing denial of service on this application. But let's say we're taking the route of the user in Singapore who's requesting content through the load balancer. At this point, the load balancer will look at the backends that have been configured and look at the ways that the instances have been deployed. In this example, there's some instances deployed in the Asia East region and also in the Asia Northeast region, which is Taiwan and Japan, respectively. In this scenario, the cloud load balancer actually takes care of auto scaling for the backends. Firstly, by looking at which instances have available capacity. There's a limit or throttle at 10 gigabits per second per instance. So if the load balancer notices that traffic is reaching that limit or has reached that limit, it'll fail over to other instances. And also, if it realizes that a particular region has reached capacity, it'll also fail over to other regions that have been set up. So that's how the cloud load balancing can also help with DDoS attacks, in that the traffic will be directed towards backends which have autoscaling enabled and will be able to absorb the attacks coming in if they happen to still go past the edge network and into the network environment of your GCP VPC. So just to reiterate, Project Shield's defenses are all available on Google Cloud Platform, which has inherent protection against denial of service attacks because of its nature of being a high-capacity global network. And a lot of the technologies that we use to protect our own users have been externalized and put into these services for customers of Google Cloud Platform to use through the load balancer and CDN. However, we know that some customers have other requirements that are specific requirements, and for that we have a whole range of third-party providers that can integrate with GCP, and some of them are listed here, but they allow you to extend your DDoS protection for specific requirements, such as, in some examples, supporting the showing of a recapture code where you have to manually type something in to prevent denial of service attacks and to slow down the rate or prevent actual requests from being submitted. Okay, so to recap, we started with looking at secure VPCs, which are the method for isolating your networks. They are controlled by identity and access management, and they have a whole host of features on setting up your instances, such as setting up firewalls, controlling private access to Google services, or enabling private access so you don't have to have externalized VMs, and also models to connect to those instances, for example, through Bastion hosts. As we broaden out the circle, we looked at direct peering options, as well as interconnect and VPN technologies, which allow you to connect into Google's network and to your VPC network from your environments or your other cloud provider environments. And then on top of that, once you've got applications set up and networks set up on GCP, you can deploy our identity-aware proxy to have identity-based access control, to take the effort of building that authorization and user-based authorization and permissioning off your developers, but abstract that and use this service, which is actually something we've deployed internally and use today to make most of our services at Google for Google's employees accessible through the internet. And then on top of that, we have the Cloud Load Balancer CDN, which provides protections against DDoS attacks through the global network, as well as third-party providers who can augment that. So to close, I just wanted to share a quote from a customer who moved to GCP last year, Evernote, and it was a huge endorsement from them to say to us that they were not only able to match the security capability that they had, but to actually improve on it. So our goal today, I guess, was to educate you guys and give you a little bit of insight onto how you can secure your workloads and on GCP and some of the features that are available to make that happen. And we hope that you'll be able to make use of some of that and get started. And to do that, I'd like to refer you to some of these resources that we have available. We have some training resources, some hands-on labs on Quick Labs and Coursera, and the ability to get in touch with us or a partner who provide implementation services. But most importantly, why don't you just get started with a free trial and get hands-on? That's the best way to learn. You can sign up for a free trial that gives you the ability to set up projects and set up resources and play with any of these technologies that I've talked about today. So I'm just going to invite my colleague onto the screen, and we're going to go through some of the questions that have come through. Welcome back, everyone. I've got here with me my colleague, Malcolm Holden, who's a customer engineer based in Sydney. Hi, Malcolm.
Hi, Liam. Hi, everybody.
Great. So it looks like we've got some questions to go through.
We sure do. So let's start off with the top one. And I think you touched on certificates and SSH security, etc., through the presentation. But the question came up: can I use certificates to encrypt data I store on Google Cloud Platform?
Yeah, that's a good point. I didn't really talk about this. I mentioned it in the infrastructure stack, but there are a couple of options here. The first one is something we call customer supplied encryption keys, which let you encrypt data that you put into Google Cloud Storage. And I guess it depends what kind of storage mechanism you're using on Cloud Platform. But for Google Cloud Storage, which is our blob storage, you can actually store encryption keys through the Cloud Console, which can be used to encrypt your data, and then set permissions on those to only allow access to certain people or groups to access that encryption key to unlock your data, decrypt the data.
Right, but if I don't provide my own keys, everything's still secure, right?
That is true. So we have, as I mentioned, we have encryption in transit over the wire, but also at rest within Google Cloud Platform. So by default, all of our services encrypt data, and within our data centers, it's stored, sharded, stored, encrypted. And we've actually got a white paper, which I'll refer our viewers to look at, which talks in great detail, more detail than you probably want, about some of the encryption keys and technologies we use internally to secure the data.
Yeah, one of the things I like is, we play around a lot with the services on Google Cloud Platform and see how they're going to work together for customers. One of the services I particularly like is the ability to get SSH certificates inside the browser, so I don't have to manually do that when I'm doing my testing and development. I click on the SSH key, certificates downloaded for me, managed for me. It makes it pretty seamless, doesn't it?
Yeah, that's right. Yeah, the capability through that natively through the browser is something that a lot of customers are finding helpful.
Yeah, it's certainly, it makes it easier for people like me.
One thing actually I wanted to add on to that was recently we launched the Cloud Key Management Service. That's ability to have encryption keys that are managed by Google. You can't upload your own keys to that yet, but it's a service which lets you encrypt any data in any application. So you can connect to it programmatically through API, and you can encrypt your data by keys that are managed and secured through IAM through this key management service. So that's a new service that's, I think, in beta, but launched into beta recently. In fact, it may even be GA. But I'd have to double check. But that allows you to build your applications and take advantage of encryption processes that are provided as a service instead of having to develop those yourselves. Which is
cool. So bottom line, everything's encrypted at rest in transit. We can, we'll manage the keys for you. If you want your own keys, you can bring them along, and there are a couple of services there to make it easier for you.
Exactly.
Perfect. Excellent. So next question is around. Let me just bring it up here. What security analytics capabilities do we have in Google Cloud Platform that people can use and find helpful?
Yeah, that's a good question. So natively on Google Cloud Platform, we've got a service called Stackdriver, which is actually an acquisition we made a couple of years ago. This is a service that lets you aggregate log data across your services. In fact, across both GCP and Amazon Web Services as well as the support for other through an agent, you can collect logs from other systems as well. But what that does is aggregates all the logs and also allows you to perform monitoring on metrics that are predefined in GCP, but also you can create custom metrics based on your logs to alert you in different ways to security incidents or things that happen.
Right, so because it's all on the logs, you can set alerts up and triggers. So if something does happen, if an issue comes up or a detected issue, we can set alerts off that one.
Yeah, exactly.
Now, some customers have, systems like Splunk and Tenable and things like that. What's our connection to those applications?
Yeah, that's actually, we've actually got some connectors from Stackdriver into those systems. And on our website, we've got a number of providers which have integrated with Stackdriver because obviously, we know people don't always use Stackdriver, they've got their own systems. So that's a way for customers to export the data directly from Stackdriver into those systems to perform their own analysis.
So they can manage their own security information event monitoring services there.
Yeah, exactly.
Perfect. So another question. Some of our services on the Google Cloud Platform are essentially multi-tenanted. So they're shared between tenants or between organizations. What steps do we put in place to make sure that stays secure?
That is another good question. It comes up a lot because, as you might expect, GCP is designed as a multi-tenant architecture and platform. So you have other companies using the same infrastructure. But I'd probably first start by talking about the virtual private clouds that you can configure on GCP, which provide that installation or isolation of your resources from other projects, even your own projects. So that would be the first method of protecting your resources. But also there's a concept of service accounts in GCP, which are a type of user a special type of user where you can use for application-to-application communication.
Okay,
and you can set up applications or instances to run as service accounts, and then protect your data based on those service accounts, and set permissions on those service accounts, such as this service account only has the ability to update cloud storage, but not access a Cloud SQL database, a MySQL database on GCP. So you can actually lock down the least privilege permissions on those service accounts, so that the application should only access what it has access to, and the data should only be accessed by a particular account.
Cool. The other thing, early on in your presentation, you had that beautiful picture of a boiled egg getting cracked open, right?
Yes.
And I think that kind of speaks to Google's, general practice that we trust no one, right? So all our systems have been designed from the ground up, under that basis. We trust no one until, trust is defined, right? So I think as a result of that, our infrastructure is largely set up from the ground, or designed from the ground up, to be multi-tenanted and protects the data, the security access accordingly.
Yeah, that's right. And again, I'd refer our listeners to looking at the recent white paper about infrastructure security, which goes into that in great depth, along with a few other white papers that link from there.
Right.
And it's quite interesting to read about how that's designed, because, as you mentioned, the concept of trusting no one is inherent in the way we've designed each layer of that stack, which I talked about earlier.
Right, and I think that white paper, I mean, it's been a little while since I've looked at it, I probably should refresh, talks about different ways to isolate and sandbox things from a development perspective or testing perspective.
Yep, there's a bit of resources around that as well that our viewers can look into. So
the last question on the slide was, and I think you might have mentioned it briefly, but can I have a private peering directly with Google for my own network into my VPC on the cloud?
That's a good question. So yeah, we know a lot of companies want to have direct connectivity on a private IP address space to their private IP address space in Google Cloud. Currently, we don't have the ability to go directly across the network like that, apart from using a cloud VPN service. But we do know this is, particularly for large organizations, a requirement that comes up a lot. So our product and networking teams are looking at this one very closely. We don't have anything we can share about right now, but stay tuned and watch that space.
So watch this space. But there are some new announcements coming out. We made some new announcements a month or so ago at Next around things like data loss prevention for Google Storage. So the ability to use the data loss prevention API to look across storage buckets and data store for personally identifiable information like credit cards and things like that, to make sure that doesn't go outside the enterprise. So there's some new features coming out all the time, essentially.
Yeah, that's right. Yeah, we didn't touch much on data. We kind of focused on the infrastructure and access controls.
Yeah.
But there's a whole bunch of resources out there around how data's secured, how it's encrypted, how you can use the new DLP, data loss prevention API, to identify sensitive data in your data, so you can redact or identify and tag those bits of information. So definitely worth looking into those as well.
Now the other thing is we run a number of third-party audits regularly, where auditors come in and look at our security compliance, look at how we implement our security systems, and they're available for people to go and have a look at as well, right? So they're up there on the website. Yeah,
that's a very good point too. One of the first questions, particularly with regulated organizations or regulated industries, financial organizations, they ask about what kind of certifications do we have, what kind of checks have been done. But if you go to the security section of our website, you can go through all the certifications and investigations that have been done, and also get copies of those reports to dig into in more detail, which may help even companies that aren't heavily regulated.
Fantastic. I think that's the end of the questions.
Great.
Any more?
No. Well, again, just to wrap, I'd like to refer you back to the resources that we have to get started and to get trained up. But we want to thank you all for your time joining for today, and we look forward to speaking with you or joining with us on another webinar soon. Thanks, guys.
Thanks, people. Bye.